We're going to look at analyzing implicit functions here. So remember, implicit functions are something where you've got y's on both sides, or you've got a y squared in there, or something where it's not just y equals f of x. And some of our math needs to change a little, or we need to put in special considerations as we solve these. So when we're analyzing implicit functions, the same ideas can be applied. We don't have to do anything special, but the specifics do look a little bit different. So critical points are where the derivative is 0 or undefined. And in this case, though, we do need to consider both that there are x and y values, no longer just x values. So our first example, find the vertical tangent lines for 3x squared plus 6x minus y squared plus 8y equals 16. So a vertical tangent line is where dy by dx equals plus or minus infinity, where the slope is undefined. So let's take our derivative here at the start, and remember we're going to need to use implicit differentiation. 6x plus 6 minus 2y prime plus 8y prime equals 0. That means we're going to have y prime times 8 minus 2y. I'm doing a bit of this kind of quickly in my head. If you're having trouble following along, you can pause or ask me about it in class. It was negative 6x minus 6. Y prime is equal to 6x minus 6 over 2y minus 8. And I just wanted to get rid of these negatives. That should be plus. So I just multiplied the top and bottom by negative 1. Let's let things slip around. So I need to find where this is undefined because it's equal to plus or minus infinity. Well, the way it gets to plus or minus infinity is if our bottom approaches 0 while our top approaches something that's not 0. So in other words, for y equals 4, this will approach infinity. But now we need to find the actual tangent line, which is going to mean that we need to find the value for x, because a tangent line is an x value. So we know it happens when y equals 4, so let's go back to our original equation and find where, when y equals 4, what does x equal? So 3x squared plus 6x minus 4 squared plus 8 times 4 is equal to 16. 3x squared plus 6x, this is 16, so when I add that I'll get 32 on the left. This is 32, when I subtract it I'll get 0, so this equals 0. This is going to work out quite nicely here. Pull out an x and I get 3x plus 6 equals 0. So x equals 0 and negative 2. So these are our vertical tangent lines, x equals 0 and x equals negative 2. You can go ahead and graph this function and see that at 0 and negative 2, it should indeed go vertical. For our second example, we're going to find the local extrema for the function x cubed plus xy equals negative 2. So first we need to find the derivative. So we take the derivative of both sides, 3x squared plus xy prime plus y equals 0. Xy prime is equal to negative y minus 3x squared. Y prime is equal to negative 3x squared minus y over x. I just switched those because it's easier for my brain to take a look at that. Now we want this to equal to 0. So we need to start finding values where this will equal 0. Well, we know that it doesn't matter what the denominator is. If the numerator is equal to 0, the whole fraction becomes 0. So in other words, we're just going to look at 3x squared minus y is equal to 0. So if we bring that up here, we have that y is equal to 3x squared. And so what this actually means is all of these points are where we could get potential, these are all places where the slope goes flat. So which of these are actually on our original function? Let's find out. So x cubed plus x times 3x squared is equal to negative 2. So what we're doing here is we found all the places where the slope could be equal to 0, but not all these places actually are on our function. So we need to plug this in to see which x values are in our function that are also places where the slope could be 0. So if we do this, we get x cubed plus 3x cubed is equal to negative 2. 3x to the 4th is equal to negative 2. X to the, so that should be 4x to the 3rd is equal to negative x to the, I've made quite the mess here. Let me clear this out and start that again. This would be 4x cubed is equal to negative 2. X cubed is equal to negative 1/2. So x is equal to the cube root of negative 1/2. So this is one of our critical points. I'll leave it to you to go back and plug that into our function, and you can look at a point to the left and right and figure out whether this is a local minimum or local maximum. But that is where that local extrema could occur. And if you have any questions, check with me in class.